also Aras Pranckevičius.
Hello. Yeah, so someone asked me to, hey, can you talk about Unity's scriptable render pipelines? And I was like, do I have to? And they said yes. So here I am. So since we are out of time, I have about -5 minutes left, so I'm going to be really fast. Does any of you actually know what the hell is scriptable render pipelines in Unity? Anyone? Yeah. Okay, so about like people who work at Unity, I see. Does anyone has no idea what Unity or scriptable pipelines is? Okay, and maybe you don't even want to know. So like if you don't want to know, just sort of slowly rise up, go have some life or something, I don't know. Because I think what I'm going to talk about, for anyone who knows Unity, that's going to be like super obvious. For anyone who doesn't know Unity, probably not going to understand anything what I'm saying. So I guess the only hope is that if you are interested in that and you don't understand anything, then you can ask me questions or something. So let's go. That guy. Now, what is scriptable render pipeline is basically, we looked at the way Unity has developed over the last 10 or 12 years or whatever, and towards end of year 10 or year 12, the rendering pipeline that was built into Unity was becoming really, really complicated, and it had like a bunch of these things, like it can do either forward or deferred rendering. It has a lot of settings that are hard to find and hard to understand, and these are scattered in like 12 million different places, and people cannot even find them or know which ones that they should be tweaking. The other problem happened that people would often say that, for example, Unreal looks better out of the box with all the default settings, whereas Unity can actually achieve pretty much the same look, but you have to find 78 settings and tweak them just to the right values, which was a problem. The other problem was that the built-in pipelines, since they grew over like a period of 10 years, they became just a mess of workarounds and sort of things. Because if you remember computer graphics from 10 plus years ago, it used to look slightly different from what it looks today. Like 12 years ago, Xbox 360 and PS3 were just getting started, right? And now Xbox One and PS4 is kind of towards the middle or end of their lifetime or something like that. Or on PC, you know, like 12 years ago, it used to be like, I don't even remember what it was, but it used to be slightly less impressive and slightly less capable. Anyway, the good thing is that despite all the shortcomings of Unity's black box rendering pipeline being complex and whatever, it actually enables quite many games. So if people know what they're doing, they can achieve pretty unique and pretty distinct look from the Unity games, and there like isn't like Unity look that people could look at all these screenshots and say, hey, yeah, that's Unity. Of course, a lot of people who don't know what they're doing, they end up using default light setup and default shaders and default whatever, make a game out of default Unity spheres, and then you can look at that and say, yeah, this is like default skybox or whatever you have in there. So personally, as an ex-graphics programmer, I'm actually pretty happy that people have achieved all these sort of very different looking and different genres of games in our existing rendering pipeline. So maybe it wasn't like all that bad. However, I don't know, like at some point it became clear that it's really hard to just keep on improving our current rendering pipeline while also keeping it working and making it easier to use and making it look better out of the box and yada yada. So if you look at like traditional rendering pipeline of any game, basically it's comprised of like, you could say like high level logic, which is like the interesting part, which is like the algorithm that computes lighting and computes shadows and shading and reflections and fog and whatever, right? And then there's kind of the boring parts, which I call plumbing, maybe, which is kind of the low-level abstractions of the engine, how do you make it work on a console, how do you make it work on a mobile, how do you make it work on like Vulkan and DX11 and DX12, whatever, right? And traditionally, and in Unity, and also in Unreal and in countless other engines, it has been that all these sort of the high-level logic and the low-level logic is written in C++ programming language, and there's also bits in like shading languages like HLSL or CUDA or whatever scattered around. And we had that in Unity, and we don't actually want that. What we wanted to do with the new scriptable render pipelines is basically make the graphics engine of Unity kind of like, you could say, open source, in a sense where the source code of all the algorithms that we use for lighting, for post-processing, for shadows, for volumetric lighting, for particles, whatever, right? That would be just out there for you to look at, so you could actually understand, modify it, extend it, maybe remove parts that you don't need, etc. And we also wanted to make it sort of more modern. A bunch of decisions and a bunch of things in the existing Unity's graphics engine were made in like year 2005 or something, when the whole landscape was very different in terms of platforms and in terms of what the GPUs can actually do. And we also wanted to make it more performant out of the box than the built-in pipelines. So what we decided on was basically to write the high-level logic in sort of C# and make it open source or source available. It's just out there on GitHub. You can look at it, you can modify it, whatever. And the low-level layers are sort of written in C++, which is like in the actual engine part of Unity. And the concept is actually fairly simple. If you look at any rendering algorithm, it basically it operates on sets of objects. You determine what is visible, and you render some subset of things that are visible with different shaders or different parameters into different render targets, whatever. So that is basically the concept, that the engine, like the Unity built-in engine, provides APIs to determine what is visible, to determine which lights are potentially visible or affect visible sets of objects, and then to render subsets of them. So the idea is actually very, very simple. It's explained in like more detail in various blogs. In various slides, I'm gonna have links to like either Unity blogs or to some talks that goes in more detail. So obviously, during my presentation, you cannot just click on a link and go there. But I think I'm gonna put the slides into like, I don't know, just post them on the Facebook event or whatever, right? So you can click on them later. I already talked about that, so let's just move on. The advantages that we hope to achieve with a scriptable render pipeline is that, as I mentioned before, all the interesting bits are written in C#, and they are just out there for you to modify or look at or investigate or learn how to do things from. And you can quickly iterate on your rendering algorithm if you're writing your own rendering pipeline. It also has a bunch of disadvantages. For example, today, if you take a modern Unity version and use one of the built-in rendering pipelines, then a bunch of shaders that have worked previously don't work with them anymore because they need to be written in a different way. So for example, if you, I don't know, if over 5 years you have written 7 billion shaders on your own, then they will not work with a new rendering pipeline anymore unless you make changes for them to comply to the shader structure that the rendering pipelines demand. Or if you have bought, like, I don't know, like from the asset store, if you have bought shader packs for $7 billion or something, then they will not work with the new rendering pipeline anymore. Sorry. The good thing is that finally Unity has a visual shader editor, just like similar to what Unreal has, and apparently it sometimes works or something. And the shader graph is actually meant to work with the scriptable render pipelines, so it can produce shaders and materials without writing actual HLSL code. You just noodle around with the noodles. The other big disadvantage today is that we haven't written proper documentation for all that shit, or all that stuff yet. So it's it's a typical setup in development where most developers don't want to spend time documenting things. They want to code, right? So they go and code, and then someone, or maybe if they feel like it, they write some documentation. So the documentation part right now is a bit lacking. So for example, if you want to understand how the HD render pipeline actually works, your option today is look at the source code. And the source code, of course, it's there, which is great, but it's also like, I don't know, by now it's like 20,000 lines of code or something, so like, good luck. The other downsides or disadvantages today are fairly minor, I would think. Like in the past, if you wanted to extend the built-in rendering pipeline, you basically needed Unity to add new feature. Today with the scriptable render pipeline, it's less of an issue, but for example, NVIDIA just shipped the new GPUs that support ray tracing or whatever that is, right? So, no, it's good. So like right now in Unity, there's no way to use the DXR API or whatever the Vulkan extensions for ray tracing. It will get there, but to use the new NVIDIA ray tracing things, you still need a new Unity version. You cannot just code that on your own. So today in Unity, we're shipping basically out of the box with 2 rendering pipelines. One of them we call lightweight, which is initially we called it like low end, but low end is a bad term for marketing, which is the shitty pipeline, right? So we call it lightweight, and this is basically targeted at, it works on all the platforms, on even all GPUs and all GPUs that are not fast enough, and it's sort of optimized for mobile or VR use cases. It's actually often more performant than the built-in rendering pipelines that Unity had, just because it's guaranteed single pass forward render, as opposed to the previous Unity built-in pipeline, which could do like multiple passes as soon as you use a point light or something. And then we have sort of the HD render pipeline, or like high definition render pipeline, which has like all the fancy features that a graphics engine today should have, which is like subsurface scattering, and all these other things that I'm too lazy to spell out. And it's sort of like a modern take on the graphics engine, you would say. So I know people love to compare like Unity versus Unreal. So like my personal take as a totally unbiased opinion, right? And hey, I'm not even a graphics programmer anymore. So my personal take is that it already has some features that Unreal still doesn't have. For example, it has iridescent materials using much better shading model than what Unreal has. And it has like more area lights, more area light options or something like that. And there was a talk just like a month ago, yeah, I think so. Just a month ago from one of the authors of the G-Render pipeline at SIGGRAPH conference explaining all the details behind it and all the sort of advances that in like graphics research that we're doing and putting into this pipeline. So this one is basically targeted at PC or consoles. And by consoles, I mean today that's going to be PS4 or Xbox. It doesn't work on Switch yet. I'm not sure whether it will, maybe not. Like I don't actually know that. But this is kind of the high end. Like today, it probably doesn't even actually work on mobile, sort of by design. Maybe at some point it will, but it works. Kind of works, yeah. Like. Yeah, like the source code is out there, so you can just make it work, right, on your own. Good luck. But in a lot of game projects that are being developed in Unity right now by like various sort of semi-big game studios, most of them I cannot talk about. A lot of them are actually using high-definition render pipeline right now to actually pretty good results, and they're fairly happy. So once these games are out, then maybe they will actually be good, and we will be happy about graphics in Unity for once. Yeah, and as I said, the source code for both of these is just out there, like full everything. All the shaders, all the compute shaders, all the scripts, everything is out there. You can actually look and see who actually commits code if you like to stalk people or something. And then we have a couple of resources for people who want to either modify the built-in pipelines. So there's like, again, a link that's too long for right now, but once you get to the slides, you can just click on them. And we also have some resources for people who want to build their own rendering pipeline from scratch. If for whatever reason you don't like or you don't need the functionality of the tool that we ship. For example, if you're making something that's using a very non-realistic rendering in the first place, or if you have some really special requirements, like, I don't know, like if you're building like a point-based renderer that doesn't even use triangles anywhere, well, whatever, right? So that was it for me. I have no idea whether that was useful, but you can ask me questions.
So this boat attack example is a screenshot we have seen in the lightweight?
Yeah, I think so.
Or do you have these cool ones?
So the forest demo, I think we shipped the project for that one. It was on the Unity blog somewhere. I think that we shipped the project for like the. It was like the. So the top one, I think, is as forest scene from the Book of the Dead demo, and that was definitely shipped as a project. Not the full demo, but just the forest, like a forest scene. The bottom one, I think it's from a different project that I'm not sure whether.
So it should be somewhere in examples section of the GitHub?
I think
it should be somewhere
asset store.
In assets.
Yeah, in the asset store.
You can see Book of the Dead came on this year, by the way, and there will also be a talk by Unity about it.
Oh, okay. I didn't know that. So cool. All right. Oh, I do remember. Yes, someone will talk. Yeah, okay. I got it out of my head. Yeah. Okay, please ask me one more question.
Ture,
What about GDPR?
Sucks.
But this is not GDPR, this is HDRP, which is close, but not. Yeah, okay.
But did you code it with GDPR in mind, like from the start?
Good question. I hope, or I think it doesn't collect any data. So.
Could you explain a scriptable render pipeline to a 3-year-old?
Okay, so after you explain the GPI and how the passwords are hashed using rabbits and tortoises or something, I will explain the rendering pipeline. Let's make a deal.
Basically, the stuff that makes the code visible and on the screen.
Stuff that makes things on screen, right? Shiny pixels and not so shiny pixels.
So how do you start using those pipelines? Is it built in Unity, or do you have to download them?
So in Unity 2000 maybe. Yeah, in any 2018 version, when you create a new project, there's a bunch of presets, and I think the default one is like 3D using the legacy built-in pipelines, and there's also like HD render pipeline preset, whatever. If you don't want that, and you like have an existing project or something, in also like 2017 dot something, we started to have this thing like a package manager. So they are packages basically. So you find them, you install them into your project, and both the lightweight and the HD pipelines have this then menu item sort of upgrade all your materials to use the new materials. So if your existing materials more or less map to the standard shader type of setup, then they will more or less will upgrade. Maybe will upgrade fine.
Yeah. What about all the rendering settings in all the different places? Are they gone when you start using them?
Yeah. I think we for rendering settings that are not relevant when using the rendering pipeline, we hide them from the inspector when the rendering pipeline is active, and then they have their own settings somewhere. It's usually on the like in a single place on the render pipeline assets itself. So you define like your shadow resolutions and whatever in there. And also some of the things have more settings. So for example, in HD render pipeline, the light has more settings. So like, for example, spotlights not only have the cone, but also the inner cone and like the physical light units instead of arbitrary floats and stuff like that. So yeah.
When is Unity planning to have like a good documentation on this?
Yeah, so it's actually being worked on, I hope. Yeah, so for example, the HD render pipeline documentation is being improved. It's just, not maybe as fast as I would like or something. All right, no more questions. Good. Whew.